Imagine you're blindfolded, standing on a hilly landscape. Your only goal reached the lowest point. You can't see the whole map. You can only feel the slope beneath your feet. This is exactly how AI learns. This process is called gradient descent. Every AI model makes predictions. But in the beginning, those predictions are terrible. We measure how wrong the model is using something called a loss function. Think of it as a score of failure. The higher the loss, the worse the model. Our job is to minimize that loss. If we plot the loss against the model's parameters, the numbers it learns, we get a curve. This curve is our hilly landscape, and we need to find its lowest point. To move downhill, we need to know which direction is downhill. In mathematics, this direction is given by the gradient, the slope of the curve at any given point. If the slope is positive, we're on the right side of the hill, we need to move left. If the slope is negative, we're on the left side, we move right. We always move in the opposite direction of the gradient. This is why it's called gradient descent. We descend, step by step, following the gradient. How big is each step? That's controlled by a value called the learning rate, often written as alpha. The update rule is simple. New parameter equals old parameter minus the learning rate times the gradient. If the learning rate is too small, the model learns painfully slowly. If it's too large, it overshoots the minimum and never settles. Finding the right learning rate is one of the key challenges in training AI. Let's watch gradient descent in action. We start at a random point on the loss curve. We calculate the slope. We take a step downhill. Then we do it again and again. With each iteration, the loss gets smaller. The model gets better. Step by step, it finds the minimum. This process, repeating the update rule over and over, is called an epoch. In real AI training, this happens thousands, sometimes millions of times. Here's what happens with a learning rate that's too small. The steps are tiny. Progress is slow. It reaches the minimum, but it takes forever. Now watch what happens with a learning rate that's too large. The steps are massive. It jumps over the minimum, back and forth. It may never converge. The sweet spot, a well-tuned learning rate, moves smoothly and efficiently to the bottom. But here's a hidden danger. What if the landscape has multiple valleys? Gradient descent might slide into a small valley, a local minimum, and think it's done. But the true lowest point, the global minimum, is somewhere else entirely. This is a real challenge in deep learning. Researchers use tricks like momentum, random restarts, and advanced optimizers to escape local minima. So to summarize, gradient descent is the engine behind AI learning. It takes a loss, calculates a gradient, takes a step, and repeats until the model finds its best possible state. If you found this helpful, subscribe to Vector Shield, where we make AI make sense.